Forces in Blender are used to influence the movement of dynamic objects or particles. One type of force that you're already familiar with is gravity, and you can find the settings for that in the Scene Properties tab if you want to change its speed or direction. So with this simple particle system, you can see that it's falling down due to gravity, but as soon as we uncheck gravity, the particles are just going to float in space since there are no forces acting on them. But there are a lot more types of forces that we can use in Blender, and we can access them with force fields. The quickest way to add a force field is to go to the Add menu, up to Force Field, and for now let's just click on Force. Now if we play back our animation, you can see that the particles are being pushed away from the force field. The settings for force fields can be found in the Physics tab. The strength of the force field determines how much the particles are influenced. So if we turn this up, let's just turn it to 10, then we can see the particles are being pushed away much faster. And if we give this a negative value, then the particles will be influenced in the opposite direction, in this case pulling it towards the force field. Now, a force field is not a unique type of object. Really all it is an empty with force field physics applied. But you can add a force field to any other type of object. For instance, we could even add a curve. Let's just add a curved circle, and we can enable a force field on that. We could also do the same for a mesh object, a surface, a metaball, text. Any object in Blender can also have a force field applied to it. But there's one other way to apply a force field, and that is to particles. So if we click on our emitter object and go to the Particles tab, under Force Field Settings, we can apply a force field. So if we choose Type 1 to be a force, and we play this back, we won't see anything happening because by default it'll only affect other particle systems and other dynamic objects. To get it to affect itself, we need to choose Self Effect. Now if we play this back, each particle is going to push all of the other particles away from it. So by default, the amount is set to 0, and that means that every single particle is its own force field, and that can cause things to be really slow if we have a lot of particles, or it's affecting lots of other particle systems as well. It can get really complex really fast. So by default it's set to 0, but if we choose this to be 10, then only 10 of the particles are going to be that force field, and they're going to push all of the other particles out of the way. So this will definitely help speed things up and will make it a little bit less complex. So if it's affecting other particle systems as well as its own, I definitely recommend setting the amount to something like 10 or a little bit higher, just so that it's not quite so complex and it won't drag your system down. So those are all of the ways in which you can add a force field. Now let's take a look at the basic settings so you can start experimenting with them right away. The shape of the force field determines where the force is emitted from. By default it's set to point, which is at the object's origin. Plane makes it a completely flat force field which only affects the z direction. Surface uses the actual shape of the object as the shape. And every point places a point on every single vertex of a mesh or curve object. Flow converts the force into an airflow velocity, which is going to slow down its effects. Noise gives the simulation some random variation, so that some particles will be affected more than others. Adjusting the seed value will give a new random pattern. Under Effect Point, there are two checkboxes for Location and Rotation. Leave these on if you want to influence the location and dynamic rotation of the particles. But in order for rotation to work, give the particles a little bit of angular velocity, and check on Dynamic in the Rotation panel of the particle settings. Collision Absorption allows collision objects to block the force field. You can independently set the amount that each collision object absorbs in its physics settings. The fall-off controls how far away the objects must be in order to be affected. The higher the power, the closer they have to be. You can also set the fall-off shape to be a tube or a cone instead of a sphere. So now that you know the basics of force fields, in the next video we're going to look at each of the different types and what they do.